Welcome to How to Make a Flo-Rater Attachment with Ally. The materials and tools needed to make your Flo-Rater attachment include a 6-inch piece of PVC pipe with a 1/2 inch diameter, an end cap for the PVC, wires, 4 wires that are 12 feet long, a AA battery pack, a AA battery, 1 Optech deep gap slotted switch light sensor, shown there, 1 330 ohm resistor, a T connector to attach it to, at least a 9-inch by 9-inch acrylic sheet, and a fan blade. I use one with an 8.5 inch diameter, and you can adjust it for what you can find. 2 bearings that fit inside on the top and the bottom to make sure that it rotates easily, a collar to raise it away from the PVC, and a bolt. I used number 1032, that's 2 inches long, to attach it to the PVC. So you'll need a drill to drill the hole in the PVC for the bolt. You'll need a hot glue gun to waterproof some things and attach certain things together. And you'll need a soldering iron for the wire attachments and some solder. And a LabQuest handheld computer. This will be used to collect the data.
The circuit has a 330 ohm resistor, which may be hard to see under the hot glue, but it is connecting the positive wire, which is green, to the signal wire, which is white, for this particular wiring. The battery is connected to the light sensor in series. Refer to the schematic to see wire connections. The color of the wires are labeled in red. Here's how it works. When the signal of the light sensor is uninterrupted, meaning a hole in the ring is over the sensor, the voltage drop across the sensor goes from the maximum voltage to 0, resulting in the maximum change. When the signal is interrupted, meaning there's material covering the signal, the voltage difference across the sensor is 0 because there is no electrical current flowing through the sensor. This results in no change in the voltage. The purpose of the inverter is to convert the current from DC to AC. The LabQuest gathers the desired data by connecting the black clasp to the black wire of the sensor and the red clasp to the white wire so that it can measure the difference in voltage from the ground, which is 0, and the signal coming from the light sensor. Obviously, different wires are being used to serve as extensions. Once it is all connected, you can check to see if it is working by moving the fan blade and seeing if the measured voltage changes from a minimum to a maximum as the ring moves through the sensor. First, make a mark outside the tank that is 1 foot deep. You'll then move the Flo-Rater from top to bottom at 3 different velocities. The velocity will be found by dividing distance by change in time. The distance is known, and the change in time will be determined when analyzing the data in Excel. From the calibration, an equation is developed to allow you to calculate the flow rate depending on the clicks per minute. The Flo-Rater does just what the name implies. It measures the flow rate of water. The measurement is taken as a fan blade rotates through a light sensor according to the velocity of the water.
Under the sea, when the sardine begin, it's music to me. What do they got? A lot of sand. We got a hot crustacean band. Each little clown here know how to jam here under the sea. Each little slug here cutting a rug here under the sea. Each little snail here know how to whale here. That's why it's hotter under the water. Yeah, we in luck here down in the muck here under the sea.